So last week, okay, so our work introducing the non-Boolean but propositional logic connectives, conditionals and biconditionals, is chapter 17. And then this week we're going to learn the intro and elim rules as well as strategies for those operators. So, on the assumption that that you don't have any outstanding questions, I'll go ahead and launch into chatting about a little bit about our review, and then also introducing the material for this week, and then we'll practice. But before I forget, so next week is actually election day. And I want to make sure that if you haven't voted already and you are planning to vote, that's your priority. I don't know what your day is like. In other words, I don't know what, various pressures you have on your time, or what pressures there are on your time. So what I can say is that, as usual, if your time block to vote is during our class meeting, please prioritize voting. It's going to be the case most likely that we will, and let me double check this. Yeah, so we're going to continue to practice a bit, but then we're going to move into our last system. And what I mean by that is the deductive system that brings together everything that we've done so far and adds a little bit to it. So it's quantifier logic, and strictly speaking, it's a system different from what we've studied in Boolean logic, and then now adding to that repertoire of skills the propositional logic, but it includes all that stuff. So we'll do a bit of that. My plan is to be as flexible as possible next week, so that we can make sure that we're voting and paying attention to the returns. Okay, so that said, I see. Yep, Berman, mail in. I know, I did mail in too. When I look at the lines of people when I see the lines of people queued up to vote for early voting, it's really impressive, and I'm so lucky I didn't have to do that. Okay, so where are we? So let's do a quick review. Where we are is this: we covered last week the conditional and biconditional. More specifically, we looked at translating from ordinary English into symbolic logic notation. And we also looked at truth definitions for the conditional and the biconditional. Okay, so, and by the way, as usual, you know that my writing is often illegible. So if there's something that you can't make out, let me know, okay? And I will try to decode it for you. But before we move forward, questions, problems, confusions about this material? Right, so translations. We looked at the following. Here's just a very handy, at least I hope, handy chart, right? So the antecedent, that is the part of the clause of an if-then sentence that goes with the if, right? The antecedent's on the left side, the then clause is on the right, right? So antecedent right? So if then would be something like this. If P, whatever the simple sentence P is, if P, then Q, right? So antecedent consequent. Remember also we talked about conditions, right? Sufficient conditions and necessary conditions. And the way that sufficient conditions and necessary conditions are expressed often in ordinary English is in terms of an if-then sentence. So if we say something like this, so driving over 95 miles an hour in a 25 mile an hour zone is a sufficient condition for being over the speed limit, right? That guarantees you're over the speed limit, right? Necessary condition, so left side. Oops. The necessary condition is what must be the case or the requirement. So an easy way to think about a necessary condition is this. It's the without which an event did not obtain, right? So think about this. Suppose I say that something like the following. If I go to the movies, then Tamim must go to the movies. Or if I go to the movies, then Tamim goes to the movies. Without Tamim, the necessary condition, without Tamim, I don't go to the movies, right? So my going guarantees that Tamim goes. We didn't spend a lot of time, but I just made reference to the fact that this sort of language is really important to topics in the sciences, specifically when we're talking about, for example, natural causation. It's also really important in topics in moral philosophy, more specifically the discussions of moral responsibility, right? So lots of times, so think about this. If you are morally responsible for what you do, then you are free. Or being morally responsible for what you do guarantees that you're free, then you must be free. So a lot of philosophers will argue that freedom is a necessary condition for moral responsibility. Without being free, you can't be morally responsible. Right. So think about now, go back to my reference to the physical sciences, for example, when we talk about natural causation, right? We think about gravity, for example, right? So being within the Earth's atmosphere guarantees, right? So if you're in the Earth's atmosphere, then you are subject to the laws of gravity, right? Stuff like that. And sorry, I just got distracted because my cat just screamed, I think, bloody murder of some sort. It was a very bizarre plaintive mule and it distracted me. Anyway, so sufficiency, necessity, that's oftentimes articulated in the if-then form, okay? Also, by the way, we didn't really talk about, I didn't give you this in the chart, but since we're talking about, causation, we can talk about this, right? So cause, effect. Okay. And then the exception to the standard if-then translation is the phrase only if. Right? So whatever comes immediately after only if goes in that consequent position, because only if is exclusive and it typically reflects a necessary condition. So before moving on, what do we think? Does this ring bells? Does this sound familiar? Questions, problems, confusions? One of my dogs likes it. I don't know if you heard her bark. So far, so good?
Yeah, I'm just listening to you explain it right now.
Okay. I'm going to take silence as approval. I won't force you to talk, I promise. All right, so translations now. Truth definitions. Recall that we have the following definition for the conditional. So the conditional is false when and only when the antecedent is true and the consequent is false. Right now, we spent a little bit of time talking about the way that we can understand the truth table or the truth definitions for the conditional. Why? Well, it seems a little bit peculiar that, for example, if a conditional claim is false when the antecedent is true but the consequent is false, but when the antecedent is false and the consequent is true, the conditional is true. In other words, well, why is that, right? Well, recall what we said, namely that the conditional, the truth definitions for the conditional mirror a valid argument. We know that an argument is valid when rephrase. We know that an argument is valid when and only when it's impossible for the conclusion to be false if the premises are true. So here's the full truth table as a reminder. And Abdul, tell me as you're looking at we're just doing review right now. Tell me as you're looking at the whiteboard if there's any of my writing that is not legible, because remember my writing is messy. So if there's something that's not legible, let me know and I'll try to decode it.
It's good so far.
So far so good? Okay. All right, so recall, here's our full truth table, right? True, true, false, false, true, false, true, false. And we have these definitions. Actually, let me do this real quick. Whoopsie. Come on, Mia. True, false, true, true. All right, so that's our conditional. So I hope recognize that the one row on which the arrow sentence, the conditional claim, is false on a truth functional interpretation is with the when the antecedent is true, the consequent is false. This mirrors validity. Right, so without getting into the really cool discussions of whether or not a conditional really is truth functional, right, and its relation to, for example, causation, right, without getting into that, we can say, okay, even if I'm a little bit perplexed as to why it would be the case that a false antecedent, false consequent yields a true claim, that seems very peculiar. So also is peculiar the row 2 and row 3, right? But if we think about validity, we should be in good shape. And then the last bit that we talked about is the biconditional or two-way conditional. So here we know that as long as the values of each of the elements is the same or equivalent, the sentence as a whole is true, which is to say the biconditional itself is true, right? So here, when P is true and Q is true, the biconditional is true. When P is false and Q is false, the biconditional is false, right? And the way that we talked about the kind of a shorthand for understanding this logical operator is the following. We said that the biconditional is the equivalence symbol. P and Q are truth functionally equivalent sentences. Now, I said truth functionally equivalent when P is, for all intents and purposes, a simple sentence, not a sentence already compounded, right? But the equality is in terms of the truth values. And then we went ahead and just drew out the whole. And as we can see,
When when the truth function is false, I forgot the term for it. What was the term for it?
biconditional. Yeah.
Biconditional. Is that true or false? Because in the second one it's false, but it says true on the biconditional.
Right. So we're looking, Abdul, correct me if I'm wrong. We're here, right?
Yes.
Okay, good. So either I made a typo or I'm not clear on what you're asking. So
Oh, okay. So if P is false and Q is false, should the biconditional be true?
yes, yes, yes. Yes, I know that's weird. But there are a couple of ways that we can go after this equivalence. The biconditional or two-way arrow tells us that effectively you either have both P and Q or you have neither. So if you have both, the sentence is true. If you have neither one, the sentence is true.
Got it.
Yeah. And here again, I mean,
Yes.
the ordinary English is the language of, for example, joint necessity and sufficiency. So here we've got the expression if and only if, which when we break down, we get, right? So if P then Q, if P then Q, and only if oh yeah, sorry, I had a little meltdown there, right? So notice that, and I'll clean this up a little bit. Notice that the P is a sufficient condition as well as a necessary condition. The Q is a necessary condition as well as a sufficient condition. So what I'm saying when I say if and only if is I'm saying when I have P, I have Q. When I have Q, I have P. What do we think? Does this ring some bells? And before moving on to our rules for the conditional and biconditional, and by rules I mean before moving on to our derivation rules, where we're going to have again a pair for each of the operators, intro and elim, for respectively conditional, biconditional. Before moving on to those, I want to make sure that you're comfortable with this material, because like with negation, conjunction, and disjunction, the derivation rules are based on the truth definitions for each of these operators. So remember we said that if we understand the conditions under which a disjunction is true, and we understand the condition under which a conjunction is true, then we understand why we have conjunction elim and disjunction elim, conjunction intro and disjunction intro. Okay? All right, so take a moment. Let me know what you're thinking. Do you think that are you in absorption mode? Are you in reminder mode? If you're in reminder mode, that's fine. And what I mean by that is this: if what I'm saying reminds you and you say, oh, yeah, I know we talked about that and I did some work on that and I remember it, and I'm comfortable with it, that's fine. But just, keep thinking about, chugging away bit by bit. In fact, if memory serves, I owe you some additional practice. I just need to, change the existing practice that I have and make sure that the notation follows our new textbook's notation. Make sure you're doing as much practice as is humanly possible. And I promise you that a little bit every day is going to be much more rewarding than trying to get a bunch done all at once. In every way possible, in my view, there is no difference between exercising a bit every day, right? Go jog, go walk, lift weights, whatever you do, whatever your thing is, you do a little bit every day. And I don't know what constitutes a little bit, varies from person to person, but you do a little bit every day, you get stronger. Do a little bit of logic every day, you get stronger. Okay? You gotta keep working on that muscle. Okay, how are we doing? So far, so good? Questions, problems, confusions? Okay, well, you're thinking, I want to make sure I share our textbook because I want to follow along with the textbook's presentation, and let's talk a bit about how we're going to make sense of these rules. So remember, 2 rules each. Conditional intro, conditional elim, biconditional intro, biconditional elim. Okay? We may not, I think we'll probably the text probably presents them in reverse order because they're less complicated. The elims for each, right? The elim for each, rather, is less complicated. So let's go to the textbook. Then we'll come back to whiteboard stuff to do practice, okay? Sorry, I didn't have, there's our textbook. I couldn't find our textbook. I got it. Ready to go. All right, so as a reminder, and I'm going to scroll down to the rule. As a reminder, what was I going to remind you? Oh, so this is about the time in class when I say to people, what was I going to say? What were we talking about? And they are like, yeah, Mia, you're not doing very well. I was going to remind you of something. I remember. Okay, here we go. As a reminder, sorry, there's something I'm trying to do here and it's not working. Hold on. Okay, as a reminder, I'm doing it now. Our work in truth functional logic, whether it's the Boolean stuff, negation, conjunction, disjunction, or the propositional stuff, conditional, biconditional, is a matter of assembling and disassembling sentences at their joints, and the joint is the connective. Okay? So we're generating sentences, introducing connectives. We're disassembling sentences or deconstructing sentences, again, by the operator. Okay? So let's take a look at this brief inference. You have the sentence P, you have the sentence P arrow Q, and then you have the inference to Q. So the rule is called conditional elimination. It is another way of talking about what's known as the mode of affirmation or affirming the antecedent, which is also called modus ponens. And modus ponens is just the Latin for affirming the antecedent, or more specifically, more precisely, I should say, mode of affirmation. Okay? So we get to use this rule in order to dismantle sentences. So take a look at this first exercise that we're given. We've got two conditional claims. We have the antecedent of one of those conditional claims affirmed effectively in its assertion at line 3. And then what we want is the consequent of line 2. Okay? So as we've done with our previous derivation practice, we say the following: what do we want to achieve? And because the conclusion of a valid argument is in the premises and just has to be extracted, that's the process of demonstration, right? Because of that fact, we look at the conclusion and we find where it is in the premises. And then we start thinking about how we can pull that conclusion out. So think about it this way. Let me go ahead and annotate, even though it's going to be ugly, because I'm using our annotation using Zoom annotation. So we want R, right? R is the consequent of this conditional claim. So in order to have R, we need to generate Q. We already have Q, then R. Right? But the tricky part is, actually, let me not do that because that's going to be confusing. Let me change the color here. We need Q, but we don't have Q. So then we ask, well, how are we going to get Q? Well, look, Q happens to be the consequent of the conditional claim at line 1. So line 1, so we want Q, right? Look at line 3. We're given P. At line 1, we're given P, then Q. Right? So here's line 1. Here's line 3. And this is going to be line 4. Right? Then this is line 2. This is line 4. And this is line 5. Now let me go back and articulate what the thises were. Line 1 is P, then Q. Line 3 is Q. Line 3 is P. Therefore, line 4, Q. Line 2 is Q, then R. Line 4 we've just derived. That's Q. Therefore, line 5 is R. Thoughts? How are we doing? Does this make sense? I'm going to go ahead and erase, because otherwise that writing will follow us. Okay. So now sorry, I should have, let's see. Let's go back. We need to work our elimination for the biconditional. Forgive me. So where's, okay. So let's do this. For the moment, let's ignore line 1. Let's look at line 2. Is it fair to say that P if and only if Q, as we saw just a little bit ago, can be understood this way? It's a truth functional equivalence. P then Q and, oopsie, that's not going to go well. Oh my gosh, I cannot do this with my right hand. This has happened before, it's terrible. Okay, there we go, got it. Right, so just a moment ago when we were working on the whiteboard, we saw that P biconditional Q is equivalent to P then Q and Q then P. And what do we know? We know that if we've got, sorry, let me rephrase. We know that the conjunction is the main connective. So we could eliminate and get the following sentences. P then Q on one line, Q then P on another. If we wanted to dismantle that conjunction. Now, if we have P, so here's where the disjunction comes in. If we have P, or we can assume P, we can generate Q by way of conditional elim, right? AKA modus ponens. Once we get Q, we can generate P, right? Again, modus ponens. So as long as you affirm one side of the biconditional, you can pull down or you can dismantle the other side. Does that make sense to say? How are we doing? What do we think? Okay, so I'm going back to our whiteboard and let's start laying out our rules. Oops. Okay, so we started with the elimination, right? So conditional elim looks like this. Right? When you have a conditional and you affirm the antecedent, you derive the consequent. Now, affirming the consequent will not give you the antecedent. In fact, if you affirm the consequent, you have basically violated validity, which is to say, you have tried to derive a conclusion that is not guaranteed. Okay, and we can talk more about that, but for the moment, let's look at a few of the mechanics. Okay, and then on the other side, sorry, I said the other side, but that probably isn't the best way to talk about it. The other elimination rule is the biconditional elimination rule, and it looks like this. And in fact, let me color code this a little bit. It might be better. Might give us a better visual. Okay. So when you have a biconditional and you affirm one side, you can infer the other. And it doesn't matter which side you affirm. So this can be tricky. So don't be surprised if you have a conditional claim and you try to affirm the consequent and pull down as a result the antecedent, because you might have mixed it up with the biconditional elimination, which does allow you to affirm either side of the biconditional. But that's because of the nature of the biconditional. So here's an alternative. When you have the biconditional, you can assert the other side, right? How are we doing? What do we think? Pretty good. Okay, so let's look at a couple of examples before we move on. So suppose that I have the following argument. Right, so I want to infer from the premises the sentence not A. A couple of things should jump out at you, namely that the consequent of the claim at line 1 is contradicted at line 2. Okay, now in some versions of the system that we're learning, you can simply infer not A using the rule modus tollens, which is the mode of denial, and it's usually just abbreviated as MT. But rather than using this rule, we're going to prove it, which is more robust. Okay, so right now, because we just have the conditional elim rule, there's no way for us to simply infer our conclusion, right? That we can't do it. So let's think strategically. Remember this. We know that if we can infer B, so we're going to get it from somewhere, right? If we can infer B, then we can generate by way of that inference and line 2 a contradiction, right? And we know that when we've generated a contradiction, depending on what we've set up, we're either going to get out of a subproof and introduce a negation, or if we're staying on the same line of the sequence we're in, we're going to assert the claim that we want. In other words, we're going to eliminate the contradiction. Okay, now let's also think about a previous strategy. Remember this. Assume your conclusion is false, generate a contradiction so that you can exit the subproof and introduce a negation. Okay? Before moving on, what do we think? Does this ring bells? Let me know. Either put a chat message in or verbally speak up, but let me know if this rings bells. Let me know if you... Okay, it does, Abdul. And you know what to do next, right? Just given what we've been studying and now what we've just talked about a little bit ago?
Yeah.
Okay, good. So...
I think so.
Good. I'm sure it does. All right, so I'm going to make our subproof a little shorter. Is Tamim and Great? It's so weird. So the icon on Grady's tile reminds me of an icon that I see on Jennifer's tile. But this is Grady, right? If not, tell me. Thank you. Okay. But how are you doing? Okay. All right. Good. Good. And Tamim, let me know if you have any question, problem, or confusion. Okay. One of
Sure,
the
I'll let you know, Professor. Thank you.
You good?
Yeah.
Okay. Okay. Good. Because the one of the things that I really like about I mean, obviously, I want to meet with everybody, but one of the things that I really like about as small a group as possible is, you should feel really comfortable about saying this isn't working or that's not working or this is good or let's do more. Really make this as much of a tutorial for yourselves as possible. Okay. All right. So let me get rid of that. Also, let me know if you want me to move quicker. Right? If I'm moving too slowly, let me know. And if I'm moving too quickly, let me know. All right, so 3 is the assumption. And what are we assuming? We're going to assume negation intro. I'm just putting that note there for myself as I get started. And then at line 4, now I'm in a position to dismantle the conditional, right? Because from lines 1 and 2, by way of conditional elim, I've achieved B. And then at line, I'm sorry, I should have put this as a in green. And now we're at line 5, we've got our contradiction intro from lines 2 and 4, and then line 6 gets us out of that, this side, out of that negation intro subproof, so we can say, oh, I've just proven that A is not the case, so I've introduced the negation, and that goes, that's the subproof from lines 3 to 5. All right, so as we're moving forward, please bear in mind the fact that we're scooping up the stuff we've already done and we're bringing it into our present. And that's important for us to remember because so much of our work is scaffolded, right? So what we've done before is going to help us make sense of what we're doing now. Also, it's the case that sometimes what we move into will click in a way that maybe earlier material didn't, but then retroactively you can make sense of that earlier material, right? And then we continue to practice with the earlier material, as you can see here in the more in the newest material that we have to learn. How are we doing? So far, so good. Okay. Here's another example that may be helpful to us. Suppose that we say if A and B, then, then C and D. Line 2 says C. Oh, no, I should do it this way. Forgive me. Line 2 says A. Line 3 says B, and then we want D, okay? So here, knowing that we want D, and knowing that D is within a conjoined sentence, right? We can eliminate the conjunction to get D. But before we can get C and D, we have to affirm the antecedent. So we need A and B so that we can dismantle that conditional to get C and D. right? So this antecedent A and B has to be affirmed. Well, how do we do that? Okay, we build the antecedent. We conjoin lines 2 and 3. So conjunction intro from lines 2 and 3. Then we dismantle the conditional at line 1. So remember, think about how many lines you need to draw the relevant inference. So for conditional elim, 2 lines yield the third. Right? Go all the way back to disjunction intro. 1 line yields the second. Okay, so conditional elim comes from lines 1 and 4. And then lastly, D comes from line 5 by conjunction elim. Okay, so how are we doing with saying, okay, I see how we're scooping up what we've done before, and now we're adding to what we already know how to do. So the notion of tactics, things like conjunction elim, strategies, things like negation intro, those remain. We're going to continue to use strategies. In fact, conditional intro and biconditional intro are both strategic rules. And remember, I'd said a little bit ago that by a strategic rule, I mean a subproof rule. Setting up a subproof, especially your structuring subproof, the one that's like the blueprint for the whole proof, right? That's your strategic rule, and only a subproof rule can serve that function. The other rules are tactical rules. So eliminating the conditional, eliminating the conjunction, conjoining 2 sentences, right? That is conjunction intro, disjunction intro. Those are all tactics, okay? And the strategic rules are such because they set the basic framework for how you're going to achieve your goal. Now, typically that goal is the conclusion of the argument, but in a particularly long and complicated proof, the goal can be basically a sub-proof, right? A nested proof, double, triple, quadruple, right? That is a sub goal rather than the goal of the argument itself. Okay. Okay, so I'm going to stop the share again, and we're going to go into our intro rules, and then let's pull all this together. Okay, so did I just scroll by what I want? Yeah, sorry. Okay. So let's take a look at the basics of this example. Notice that the conclusion of the argument is a conditional, R arrow S. 99% of the time, when your argument's conclusion is a conditional, you set up conditional intro. So we've talked a bit about strategies before. Similarly, remember, when your conclusion is a simple sentence, set up negation intro. Or sorry, I said simple sentence. When your conclusion is a negated sentence, sorry, right? A negated sentence, set up negation intro. In fact, we already know that negation intro is a strategy we can use with any argument's conclusion. It's just that sometimes we're more efficient than others by using a different subproof rule. But you can pretty much bet on what I've just said here with respect to conditionals. When your conclusion is a conditional, set up conditional intro. We'll talk about what that means. Similarly, when your conclusion is a biconditional, where's our biconditional? Did I go by it again? Tell me if I'm missing it. Oh, I'm sorry. Here's what I'm missing. I was looking for an example, but it's actually this text here. So similarly, when your conclusion is a biconditional, you set up the subproof rule, biconditional intro. Okay. So let me show you the rule, the form. Don't forget, while I'm at it, I want to remind you. Let's see. I want to remind you that we have the rule sheet for our intro and elim rules for Boolean logic. I'm going to give you obviously the strategy sheet, but also the rule sheet for not just the Boolean, but also the propositional logic rules. So when you see the conditional elim, conditional intro, biconditional elim, biconditional intro, that will be on the same sheet. And it's really good to have a rule sheet kind of right next to you when you're working. It will allow you over time, I think, to more clearly see the valid reasoning form within kind of the messiness of a given proof. Okay? All right, so I'm going to share again this whiteboard. Where's our, oh, there it is. Okay, view all whiteboards. Where'd it go? Well, for some reason, when I go into view all whiteboards, our previous whiteboards are not available. Okay, not to worry. All right, so as a reminder, to dismantle, we've got our two elimination rules. Okay. Now let's talk about the intro rules. Just for the sake of visual seamlessness, or at least I hope it's seamlessness, I'm just going to go ahead and draw a line. Okay. This might actually be better to do. Okay. So, conditional intro looks like this. So here's our main line, whatever that is, or it could be a subproof, doesn't matter. But when you indent the sequence, right, that far left vertical line helps you see, oh, this is an assumptive proof. That is the introduction of the conditional. Let's talk a little bit about what this means. Think about first what we say in ordinary English when we see the arrow, right, when we translate back out. First, if P then Q. So notice that when I want to prove a conditional claim, I want to prove that if P then Q. I'm not proving that I have P or that I have Q. I'm proving if P then Q. So what I do is I prove if P then Q on the vertical. Notice what a subproof does. Recall it says, well, let's assume that. So this assumptive step here with P says, well, if I have P, then I have Q, right? That's how the rule works. It lets us, by assuming the antecedent of the claim we want to prove and deriving the consequent of the claim we want to prove, right? Infer that, well, I've just proven on the vertical that if I have P, or when I have P, it follows I have Q. So if I have P, I have Q. Okay. Notice with the biconditional intro, it's the same thing, but twice. Okay. And I also want to highlight a couple of visuals here for us. Oops. So notice what's happening at the first assumptive step. Assume I have P, I derive Q. Now, assume I have Q, I derive P. So I have P if and only if I have Q, or if I have P, I have Q, and if I have Q, I have P, which is to say, I have P if and only if Q, I have Q. Okay, so let's think about a couple of details here. If you hark back to your Boolean logic rules, you'll remember that the disjunction elimination rule is also a successive subproof sequence rule. In other words, you have two subproofs that are on the same line, right? So disjunction elimination has us assume the left side of the disjunction, derive the sentence we want, exit the subproof, begin again. Now assume the right side of the disjunction, derive the sentence we want, exit the subproof. Two successive subproof sequences. Okay. What do we think? How are we doing? Okay. What I would like to do is this, work some examples, just so that you start to get a sense of how these rules are integrated into our existing skill set. All right, so here we go. Oops, got the eraser going. Oh, by the way, question, does anybody not like the color coding for subproofs? Some people might find that just too busy visually, so let me know, okay? But I typically will use color coding whenever possible so that especially as sequences get really long, we can see what subproof goes with what rule that we're after. Or what conclusion we're after. Okay, so here's our argument. Okay, it's not the case that A. Moreover, if it's B, then it's either A or C. In addition, it's both B and D, so it's C. Okay, I'm making sure that I've basically copied this out the way we want to have it copied. Now, remember, conditional elim and biconditional elim are tactics. So there's no subproof to deal with dismantling those. Why am I mentioning that? Well, take a look at line 2. The main operator is the arrow. We're going to want to dismantle that arrow. Why? Because we're going to want to dismantle the disjunction that's within the, that is the consequent of that arrow sentence. What else do we know? Well, line 1 is a negation, and part of the consequent of line 2 contradicts line 1, right? So let's work backward a little bit. We want C. We know that C is in the sentence A or C. So if I have A or C and I know I want C, I'll do what? I'll set up a disjunction elimination, right? But now the question is, well, how do I get A or C? Well, I get A or C by eliminating it from the conditional claim at line 2, which means I need B. I need to have B affirmed. Oh, I can see how I get B affirmed. I get B affirmed by dismantling it from line 3. Okay. How are we doing? So far, so good? And by the way, this approach is one of a couple of approaches we could take. All right, so let's now move forward. We want B. Let's get B. Conjunction elim from line 3. Now we want A or C, and we get A or C by conditional elim from lines 2 and 4. Now we must, whenever we are given or derive a disjunction, I say whenever, but let's be precise and say almost always, we're going to dismantle that disjunction where the goal is the conclusion of the argument. So let's go ahead and set up a disjunction elim. I want C so that I can get out and say C, right? So 7, 8, 9, 10, 11. So what's going on? What do we need to fill in? And I'm starting us off, but then you're going to start to fill in some of the elements here with me as we move forward and work more practice. So we know that 1 and 6 are contradictories. And then we eliminate the contradiction. Then we reiterate line 9 at line 10. And then we say at line 11 that we've gone ahead and successfully dismantled the disjunction. So disjunction elim from lines 5, 6 to 8, and 9 to 10. Working backwards still, line 10 is a reiteration of line 9. Line 9 itself is an assumption. Line 8 is the elimination of the contradiction at line 7. Line 7 is the introduction of the contradiction from lines 1 and 6. Line 6 itself is an assumption, and we've already filled in the citations and justifications for 4 and 5. So what do you notice of our 4 new rules, right? We've integrated 1 into this exercise. What do you think? Questions, problems, confusions on this one?
I'm not sure why we need line 4 at all.
Okay, say more, Abdul. So we do need it, but what's more important than me saying we need it is you talking through why you think we don't need it.
Sorry.
Don't apologize. We're in no rush. Take time. Take your time.
Let's see what I was thinking. Kind of lost train of thought. So it says conjunction elimination from line 3, right?
Yes.
But couldn't we also derive B from line 2 if you did conditional elimination?
Great question. No, here's my snotty, obnoxious answer. The rule won't let you do that. But let's talk more. Let's talk about this in a way that I hope will help. So, if you say, I was thinking of an ordinary English example, but let me stick with just the letters for now. So, if B, then either A or C. Does it make sense to say that in the context of that if-then sentence, we don't know if we have B or not?
Yeah.
Okay. So we can't simply say that we have A or C until we say explicitly that we do have B. Right? So
that makes sense.
Yeah, is that a little bit better? So B arrow, A or C. We can't say we have A or C until we assert, make explicit that we have B. And again, the sentence by itself, oops, sorry, let me rephrase this. By itself, the if-then claim does not tell us we have B.
All right, that makes sense.
Yeah, okay. And one of the things that I think might be happening, although I'm not sure, but I think what's happening is this. The process of dismantling the conjunction at line 3 so that we can say explicitly that we do have B, it might feel like an overkill or tedious, but we know we have B. See, it says it, B and D. But just as a reminder, this is the microscopic, forensic accounting bookkeeping, if you will, that logic is in terms of working derivations. We always simplify as much as we can according to the rules that we use that are within our system. We simplify, and then build up. Or if we're starting with something as simple as, a simple sentence, then we build, right? So we're always simplifying and then building. And it's always going to be the case that there is no, logic doesn't know from saying, yeah, but B's right there. It's there in that conjunction sentence. Logic needs to know that B is on its own. I mean, I know that's not a very technically satisfying way to talk about it, but that might help a little bit as well.
Yeah, it doesn't, but it does explain why B is there.
Okay.
Thank you.
Of course. All right, so let's keep going. The other thing I'm wondering, by the way, after you had made your last remark, Abdul, is this. I'm wondering if, because in our ordinary ways of speaking, and I honestly don't know if this works, let's say, across languages, although my suspicion is that there's at least an analog across languages. So anybody who speaks multiple languages is in a really amazing position. You know, the flexibility and breadth, conceptual options that you have are just really, really impressive. So if there's an analog, and if any of you speak more than one language, then, you know, tell me how you might conceive of this in another language. But ordinary English if-then sentences, they, you know, we've talked about this a little bit before, they can feel really slippery. We don't always use them in ways that we're using them here in truth functional logic, where we have a defined rule for understanding what makes a conditional true and what makes a conditional false. And so but that said, I hope that just almost intuitively, when we see if then, and we just say if this then that, the if is not an assertion by itself. It's a hypothetical. And the only way that we can be more definitive is when we either affirm the if part or deny the then part. That tells us something definitive about the conditional claim elements. But the conditional claim by itself just says if then. All right, so how about, so we tried that one. Let's work this one. A, then, B, and C. Oh, by the way, tell me if you want to work some ordinary English arguments work arguments in the following way: translate from ordinary English into symbolic logic notation, and then work a derivation, right? Because that's also a really helpful way to pull a number of conceptual threads through, and some skills. Line 2 is not B and D, and then we want, which one was that? That's not, okay, so not A. All right, so here we know we want the sentence, it's not the case that A, right? We know that A is the antecedent of a conditional claim. So the only way we're going to be able to pull down the antecedent of a conditional claim is if we can derive its negation. Okay? So if it helps any to, you know, going back to what Abdul was asking about with respect to pulling off the, you know, the antecedent, think about something that sort of pumps our intuition a little bit. How about this? If I have 10 pennies, then I have 10 cents. The only way for me to know that I have 10 cents is if I say I have 10 pennies, right? It's the only way to get at that consequent. Right? Now let's think about how we can dismantle by way of deriving the negation of the antecedent. So now same premise, or sorry, same first premise. If I have 10 pennies, then I have 10 cents. I don't have 10 cents. So I don't have 10 pennies. Give each a look and tell me if you have, if the process of inference making makes sense to you. So this goes if P then C. So if I have 10 pennies and I have 10 cents, I have 10 pennies, so I have 10 cents. This reasoning goes as follows. Same first premise, but here the consequent is rejected. Right? So we say, if I have 10 pennies, then I have 10 cents. Oh, I don't have 10 cents, so I don't have 10 pennies. And I, you know, if that kind of understanding of, you know, the denominations, you know, helps you, great. If you say, yeah, that example's okay, but let's do it, let's work another one, we certainly can. Right? So what I'm after here is our grasp that the denial of the consequent is what yields a denial of the antecedent. Whereas in the first example, an affirmation of the antecedent is what yields an affirmation of the consequent. Right, so we've got affirm the antecedent, and here we have deny the consequent. Thoughts? Okay, now what
So,
sorry, go ahead.
Does that mean we can pull down the consequent with a negation?
So Abdul,
line 3, would line 3 be it's not the case that B and C? Is that possible?
it is not, and here's why. We need, in order to, let me make sure, in order to break this operator up, if you will, we're going to either need to affirm A or reject B and C as a whole.
So if we put it's not the case that B and C on third line, wouldn't that be rejecting B and C?
Yeah, so here's what I hear you saying, but tell me if that's not the case. So here's a version of the 10 pennies example. Yeah?
Yes.
Okay, now, in another version of the system, this would be useful. We could do this, and we would then justify this move by what's known as, by the rule known as modus tollens, which is mode of denial. But as with the example earlier, we don't use this rule, we prove it. We prove it by negation intro. So let me show you, and then, but I'm going to leave this up because your intuitions are quite good, right? And I don't want you to abandon them. I want you to just expand them a little bit. So here's what we're going to do. We're going to work negation intro, right? Now within this, so we've assumed A. Now we're going to be able to dismantle, right? The conditional. I've crossed out 1 and 3. Why? Because line 3 affirms the antecedent at line 1. So we end up with B conjunction C. conditional elim 1, 3, right? Line 5, and I'm going to, as usual, I messed up how much room we need. Hold tight. Should always give myself more room. Okay, so line 5, we've got a couple of options. One option is to dismantle B from line 4 first. Another option is to first dismantle the not B at line 2. Do you see where we're headed to get our contradiction? And then we'll come back, Abdul, to your really good point about the modus tollens rule. So I'll go ahead and dismantle line 4, conjunction elim from 4. Not B, so I dismantled that. I'm now going to dismantle line 2, another conjunction elim from line 2. Did I misnumber? Yeah, I did, didn't I? So 4, 5, 6, okay. Then 7 is the contradiction intro. From 5 and 6. And then we exit, let me get rid of this stuff that's in our way. Then we exit the subproof. We say lines 3 through 7, negation intro gets us not A. Now, what we've done here with this subproof starting with A, right, is another way to get at what we did over here in a shorthand. Is it fair to say that what we've done here, right, is we've contradicted the antecedent, or I'm sorry, we've contradicted the consequent, right? So B conjunction C, it's not the case that B conjunction C, these are contradictories. We're still generating a contradiction. That's here at line 7. But since we're not given the denial of the consequent as a rule, right? Instead, we're given negation intro, which includes generating a contradiction, right? We're going to use that as our way to go forward. If let's say you take the LSAT, right? You want to go to law school, you take the LSAT, you'll very likely see a modus tollens move. You'll very likely see a modus ponens move, where modus ponens is equivalent to conditional elim. In our version of the system, we have contradiction intro, which is at the heart of the modus tollens rule.
So you just did another way of introducing a contradiction and then asserting.
Beautiful.
Okay.
Good. Yeah, good for you. Yep. Nicely done. Okay, thoughts. We're going to keep practicing, but I want to know what you're thinking. What do you need that you don't have at present in terms of clarifications, examples? I'm going to, while you're thinking about that, I'm going to move on to another example, and this time we're going to work the conditional intro rule. arrow, what I use for QB. Okay. All right, so remember our strategy. When our conclusion is a conditional claim, we set up conditional intro, which is to say we assume the antecedent of the conclusion or whatever sentence we want to prove, derive the consequent, and as soon as we derive the consequent, we exit the subproof and we say, I've just proven that if I have D, I have B. Right? So remember, our subproof rules are really great for us in terms of strategic thinking. They really help us kind of see the whole of where the big picture, the bird's eye view of where we want to go and how we're going to get there. Okay. Then we start dismantling, right, and assembling as needed in order to get to get to our goal. So think about it this way: lines 3 and 4, if we conjoin, will get us the antecedent of line 2. And if we get the antecedent of line 2, if we affirm the antecedent of line 2, that will get us the consequent of line 2, which affirms the antecedent of line 1, which then gets us the consequent of line 1, which then allows us to exit the subproof. Now, just a quick kind of show of hands or comment of some sort. As I was just talking through this, did you say, okay, 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 or did you say, oh, Mia, what are you doing?
Okay, okay, okay.
Okay, all right. Anybody feeling like, Mia, what are you doing? Why are you torturing us? Okay, so let's pull stuff off to the side, right? We've assumed D. Take a look at 3 and 4. Here's 3 and 4. I'm going to conjoin them. Once I conjoin them, I can now infer A. Once I get A, I can now infer B. All by way of the all and only by way of the rules that we have at our disposal. And again, one of the nice features about the subproof rule is it says, okay, here's your structure, now go fill in the blanks. So, conjoin, eliminate, eliminate, exit. So I'm going to ask you now to fill in the blanks. So line 4 is an assumptive step. How did we get line 5?
That was conditional elim from line 2.
So you're thinking...
Oh, no, sorry. That was a conjunction introduction on line 3.
Beautiful. Thank you, Abdul. You're exactly right. Yeah, you're thinking too fast for your own good. I mean, it's great. So. It's great to think quickly, and I don't certainly I'm not criticizing you for that, but sometimes it gets us into trouble. We gloss over a step. So yeah, line 5 is conjunction intro from 2 and 3. How about 6? How did we, so 2, did I just say 2 and 3? I'm sorry, everybody. Yell at me when I do something lame. I know that means you're going to be yelling at me a lot, but sorry, 3 and 4. Okay, how do we get 6? 6 is A.
So that's definitely conditional elimination.
Beautiful. Conditional elim, lines 2 and 5. Yeah? And sorry, I want to make sure that I update our rule sheet for us, so I'm calling up the right window. Oh, I apologize, everybody. I thought that my chat was, oh, I see, that was old. Okay. I thought that my chat was in a different window than it turned out it was. Okay, Fun Fest over. Line 7. Remember, we use every line given or derived. So how did we get 7?
That's also conditional elimination from line 1.
And?
7?
Well, 7 is what we want. So we're not going to...
Sorry.
Yeah.
Line 1 and... I don't know.
So one thing I'm noticing, which is it's very, very common for us to do this, Abdul, is you're thinking about the conditional elim in terms of just the conditional itself. But the rule form looks like this. If P then Q, then we affirm the antecedent, derive the consequent. Okay, so that's one way to present the rule. Another way to present the rule is whoa. Another way to present the rule is this way. P arrow Q, P, so Q. Right, so it's always going to be the affirmation of the antecedent. So if we notice, I haven't crossed out 1, so you're exactly right. 1 is part of the process, but the antecedent of 1 is affirmed at line 6. So it's 1 and 6. Are you good with that?
Yes.
Okay. And then remember, we exited the subproof. We already set up to begin with the rule so that by the time we got to the line, we wouldn't wonder what we were doing, right? So we'd already written out, I should say, we set up the justification. So this is 4 through 7. Okay, let's keep going. See how you're doing. And as a note, so Julianne, I know, I'm glad you were able to make it. Just so you know, Julianne, what we were doing is a little bit of review of the of what we did last week. Specifically, the focus was on not on translation. It was on although we did a little chart for the conditional, but it was a bit of review on the translating and then truth definitions for conditional and biconditional. Then we moved on to our pairs of rules for the conditional and the biconditional, and that's just, and then we've been practicing. I've done some samples and just practice. So the good news is there's not a ton of new material for you to think about. It's also the case that I was telling folks that I will post more practice this time with the addition of our last, with the addition of the rules for our last 2 operators so that you can work on those. And so, the more drilling, everybody does, the better things go. But if you have questions, don't be shy about speaking up. All right. I'm going to read an ordinary English argument to you, and then I am going to, as I read through it a second time, I'm going to write out the premises and the conclusion. Either it is not the case that if the thief entered through the basement door, then she picked the lock, or else the door was not locked. If the thief entered through the basement door, then she picked the lock if and only if the door was locked. This suggests that it is not the case that if the thief entered through the basement door, then she picked the lock. Now, if you're like me, you might think there's just a lot of words flying around. I don't know, I can't, I'm not doing a good job of visualizing how the argument element should lay out, so I don't really know what the strategy is, blah, blah, blah. So if that's you and you're thinking, oh, I'm just not getting this. No. It's always good to have whether you're working a derivation or you're just reading a text, you're reading a legal brief, or you're reading a mathematical or a theory that's demonstrated by way of a number of mathematical derivations, right? Having something in front of you to sort of gnaw on and write on, that's really, really helpful, okay? All right, so here's what we have. Sentence 1. Either it is not the case that if the... Now, I lose interest very quickly. I'm already lost. But here's what I do know. The sentence starts with the word either. So that tells me that the disjunction is going to be the main connective of the sentence. So either it is not the case that if the thief entered through the basement door, so I'll make B be basement door, then she picked the lock, and I'll use P for pick the lock, right? So let me read this back. Either it is not the case that if this, then that. Right? So that's what we've got so far. Or then she picked the lock. Or else, so either or else the door was not locked. So let's say, or the door was not locked. So L for locked. Okay. So it is not the case. Door was not locked. And if the thief entered through the door, so the if then, she picked the lock, or the door was not locked. Right? So far, so good, I hope. Second sentence. If the thief entered through the basement door, then she picked the lock, if and only if the door was locked. Let's work this again, or let's work this next one. So this sentence starts with the ordinary English if, right? The conditional if. So if the thief entered through the basement door, so if entered through the basement door, then she picked the lock, so P for pick the lock, if and only if, so if this then that, if and only if the door was locked. If the thief entered through the basement door, then she picked the lock, if and only if the door was locked. Then finally, this suggests that it is not the case, so here's the conclusion. It is not the case that if the thief entered through the basement door, then she picked the lock. So this suggests that it is not the case So, couple of things. We should talk about a couple of things. First, let me tell you where this comes from. This is from a textbook by a guy named Stan Baronet. Oops. It's called Logic, and this edition is the 4th. And Stan Baronet does a really nice job. There are a number of really nice textbooks out there, so I've just stolen this exercise. Okay, so here, let's see, I was doing blue for if then. So if the thief entered, then pick the lock, and then if and only if, right? And then our conclusion, we have it is not the case. And then we have the if then. Now, a question that you might ask is, why do we have the parentheses where we do? Right, so let me know if that's something that you want to talk about. So one question for us, let's take a look at the first negation in front of the parentheses, and then also, and that's in the first premise, and then also in the conclusion, right? Why is the negation around the parentheses? So it's when we say it's not the case that, and then we assert another compound sentence, right? We're negating the entirety of that. We're negating the connective that makes up that compound sentence, right? And so we need the parentheses around it. Another way to think about a negation in front of a conditional, right? So it's the negation is rejecting the conditional itself rather than just the antecedent, is to think that we're saying that in this case, B is not sufficient for P, right? So entering through the basement is not sufficient for picking the lock. Okay. Now, when we're ready to work our work the argument, we'll have a pretty good idea of whether or not we got the translation right if we've been able to successfully derive the conclusion. Of course, successfully deriving the conclusion does not guarantee that we got the translation right, but it sure is better than not being able to get to the conclusion because we've somehow messed up the translation, okay? So when you look at the first premise, you notice that the either or is the main operator, right? And then we have the negation, right? And I'm going to go ahead and work all of the negations or right over the tilde in green. And then the arrows are blue. And then we did the biconditional in red. We know that the disjunction is the main operator in the first sentence. The biconditional is the main operator in the second sentence. And the negation is the main operator in the conclusion. Let's go ahead on to our next page. And I hope that can I copy this over? No, I guess I can't. All right, let's hope I don't mess this up. You'll correct me if I have. Actually, you know what? Let me do real quick is just copy this over. Okay. So, first premise. Okay, so as far as strategies go, take a look at the conclusion and the first premise. The first premise sets up a strategy for us, namely disjunction elim. The conclusion sets up a strategy for us, namely negation intro. In addition, we've got a tactic. Namely, we're going to want to dismantle the biconditional at line 2. Dismantling the biconditional at line 2 is going to be useful. Why? Well, take a look at the right side of the biconditional at line 2. Take a look at the right side of the disjunction at line 1. Hello, contradiction. Same with the left side of the biconditional at line 1 and the left side of the disjunction at line 1. Okay? So there are a couple of ways to go. Let's do 2 alternate proofs and tell me which one you like better. So first setup is going to be this one. And as usual, hold on, I'm going to set this up better. As usual, I don't have the, don't give us enough room, darn it. Oops. Oh, yeah, sorry. I shouldn't have done that. Shouldn't have done that either. Hold on. Okay, so what do we want to think about? Well, just because we have conditionals doesn't mean that we have to break them apart, right? We want to look at what we're given, what we want to derive, and let that guide us. That said, we could, if we need to, at any given time, dismantle a conditional, right? Does it make sense to say that we just didn't need to dismantle any of the conditional, or sorry, either of the conditionals here? Okay, so let's fill everything in. Line 3 is an assumption. Line 4 is an assumption. Line 5 is the introduction of a contradiction from lines 3 and 4. Line 6 is an assumption. Line 7 is a biconditional elimination from 2 and 6. Line 8 is the introduction of a contradiction from, oh goodness, nobody corrected me. That's supposed to be not L.
I was just about to go.
Thank you. Thanks, Abdul. You have to correct me when I mess stuff up. Contradiction intro, 6 and 7. Line 9, we're back out onto our green structuring subproof, right? So this is disjunction elim from 1, 4 to 5, 6 to 8. And then line 10, negation intro from 3 through 9. What do we think? Questions, problems, confusions. Oh, sorry, everybody. I'm running out of room. I thought I could fit this on the same page. Hold on just a sec. Let me erase this. Let me erase a little bit here. See if I can make it work. I don't think I can. I think I don't have enough room. Or I don't think I have enough room. Yeah, I'm gonna have to hold on just a sec. I'll copy this over on another page so we can see another path to working this. But while I was messing about with this, getting it started, did you have a chance to think about any questions, problems, confusions with this first approach? Is there anything that you want to go over? So far, so good. Okay, so let's do this. Let's work the same argument from a slightly different, using a slightly different strategy. Let me rephrase that. Let's work the argument using a different strategy. Right, so recall that on the previous page, we worked a negation intro, and now let's see what we get when we try for a disjunction elimination. So how does this look? Well, remember, we assume one side of the disjunction, and what we want is the conclusion. And then we assume the other side of the disjunction. And again, what we want is the conclusion. So that we can exit the proof and say, in either case, we have the conclusion. So we're setting up disjunction elim from line 1. Okay. Notice, though, we've got not L, right, which is the assumptive step for the disjunction elim that for the disjunction elim at line 1. So we're assuming the right side of the disjunction, but we're thinking two things. One is, well, how the heck do I get from not L to not B or P? And I need to dismantle line 2. But the only way to dismantle line 2 is if I have the left side of the biconditional, or I have the right side of the biconditional. But now let's think about it this way. Take a look at what is your conclusion. So remember, we're working backward from our conclusion. Our conclusion says it's not the case that B arrow P. Well, what if I assume B arrow P, generate a contradiction so I can get out and say, sorry, I accidentally hit the exit again. Come on, view all whiteboards. Give me my whiteboard back. Oh, there it is. Okay. So here we've got negation intro, right? From 6 to whenever we're done here. Right? So can you see, by assuming line 6, we're now in a position to dismantle line 2. So we get L, which then, sorry, my writing's so bad per usual. So we get L, which gets us our contradiction, right? Which gets us back out onto our main mustard line. Okay, so let's fill these lines in together, right? So assume. All right, so how do we get line 4? Remember, have your rule sheet with you. Always, 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 right? I showed you where the rule sheet that I posted is on our course homepage right under class resources. I'm going to add to that so that you'll have your intro and elim rules for the conditional and the biconditional, right? But at least have your Boolean rule sheet with you now. What do we know we can do when we make an assumptive step, right? And then we reassert that step on the next line. What have we done?
Reiterate?
Yeah, we've reiterated. And then how about 7? How did we get L? So Abdul, if you're willing to tackle this one, don't forget, biconditional elim is a 2-step citation.
If I was to guess, I would say that would be a disjunction elimination from line 1.
So you are correct that
Line 2.
you're correct that we're setting up disjunction elimination, right? But what about line 7, which is L? So where is L? L is up here, right? On the right side of a biconditional. So the question is...
sorry, we're on line 7. I thought we were on line 5.
Oh, no, you're exactly right that we've assumed the disjunction elim at line 5. Yes, you are correct. I don't want to confuse you. Yes, thank you for that. Right? And line 6 is...
line 7
yeah.
would be a conditional elimination.
Biconditional, right?
Oh, biconditional.
Do you see the
elimination
two-way
from
arrow at line
line
2? Yeah. So line 2 and... So biconditional elim works this way, or right? You need 2 lines. So you're exactly right. Line 2 is the biconditional that gets dismantled. But how is it dismantled? We've affirmed the left side at line.
Have we? 5?
Line 6. I know my lines are off a little bit. So here we are.
Okay.
Is everybody okay with that? Is it? And tell me if not just if it's not only the case that my writing is not always legible, but if for some reason the color is hard, makes it hard to see. But does everybody see line 6 is the assumptive step for that negation intro, right? So line 6 is assume B arrow P, which happens also to be the left side of the biconditional at line 2.
Yes.
Yeah? And also don't forget, folks, pull stuff off to the side, right? So think about it this way. I'm going to pull line 2 off to the side. B arrow P, biconditional L, and then I know I want L. So now the question is, how do I dismantle that? Oh, it's line 6, right? B arrow P at line 6. Okay. All right. How about the contradiction at line 8?
That's a contradiction intro from line 5 and 7.
Beautiful. Contradiction intro, 5 and 7, yep. And then we started our negation intro at line 9, color-coded red, correct? The negation intro started at line 6. Where did it end? Which line ends the contradiction intro subproof?
Line 8.
Beautiful. And then we've already, basically set ourselves up, right? At line 10, we said we were working the disjunction elim, right? So that's the mustard, right? So that was, as you pointed out earlier, Abdul, line 1, and then 3 to 4 and then 5 to 9. Okay, what do we think? How are we doing? And is it the case that you're seeing, you're grasping how it is that we are just folding in to our existing set of rules 2 more sets? One set for conditional, one set for biconditional. Questions, problems, confusions. Can we do one more?
When you do it, it makes perfect sense, but I'm not sure if I could do it by myself. Is that normal?
It's yes, Abdul. In fact, that's like, it's remarkably common, and I do the same thing myself, where depending on what I'm learning, I watch someone do it, and here's a really good one, which so I think I do this really good job of doing accents, right? So I'll hear somebody do an accent, and I'll say, oh yeah, okay, and I do the accent, and I just get laughed at, right? Now, I'm not laughing at you, and I wouldn't, because you guys are doing a great job. But Daniel's point is right. It tends to be easier to watch what's happening, because actually all you're doing is kind of recognizing something. It's the generating it yourself that just takes a little bit of time. And that's another reason why I not only advocate drilling proof completion exercises, of which I provide a bunch, but obviously also those exercises where you are constructing and completing the proof. So like a few weeks ago, Julianne said, okay, I've done all the practice from the text. I want more practice. And so I posted more. I can always post more. The more you practice, the better. And it's, so Abdul, what's great about your willingness to sort of verbalize what you're thinking is, it seems clear to me that as we're kind of warming up and getting used to this stuff, reminding ourselves about stuff, you're seeing what to do, right? Increasingly more efficiently. And so that says to me that it's just a matter of practice. And then also, don't forget, everybody, if I can do this, anybody can do it. Believe me. So if you're having any struggle at all, I think it's only because you maybe need to talk stuff out with me or Lindsay or both of us. You maybe need to talk stuff out with classmates, right? Don't be shy about setting up study groups. You also need to just drill exercises, and it's got to be with a fair amount of regularity, like a minimum of 3-4 days a week. It's like learning anything new. If you don't keep chipping away at the stuff, it's you don't really absorb it. Okay. Okay, so here's our basic structure. So this is a conditional intro structuring subproof, right? We can color code it. Then we have a disjunction elim. So that is from the disjunction, right? And so then the question is, once we've got our framework, how do we proceed? Well, when we look at the premises, we can see that we've got a contradiction, right, between line 2 and line 5, right? And from a contradiction, anything follows. And then at line 8, things are a little bit trickier, right? Because the way to get C is by having the antecedent B. But the question is, where are we going to get B? Well, we don't have it, so do we just go ahead and assume it? So let me pull this off to the side. B then C. We want C, but the only way to get it is if we have B. But we don't have B. What we do have is not B. Right? So let's see if by way of a negation intro, we can generate B. So think about it this way. If we pull line 3 off to the side, not B, then D. If we have not B, then we can derive D, right? Which generates a contradiction with line 4, right? Which then would get us, if we assume we have not B, that gets us not B and then B itself. So the way that we're going to get B is through a negation intro subproof. So let me give us a little bit more room here. Forgive me, I'm going to have to make more room as usual. Let's do this. It's when I cram stuff up or cram stuff into too small space, it's really hard for you to see. So let me fix this up. And one of the reasons why that happens is because I want to show us the structure and then start filling in the blanks. But the problem is, if I haven't given us enough room within the original structure, then we end up, things get all sort of crammed together. So I'll do this in black and then I'll change the color coding. Or I'll add color coding. All right, so we're wanting to get this red. So this was conditional intro. And then we were working green for the disjunction elim. Right, so not A or B, then C. And then let's go ahead and make blue this negation intro. All right, so my apologies for the confusion. All right, so let's number this and then let's fill in the blank. So 4 is an assumption, 5 is an assumption, 6 is an inference, 7 is an inference, 8 is an assumption, 9 is an assumption, 10 is an assumption, or sorry, I said 9 is assumption, that's correct, 10 is an inference, 11 is an inference, 12 is an inference, 13 is an inference, 14 is an inference, 15 is an inference, and 16 is an inference, and the final one. So, let's go back now to the thinking that got us the proof. First, our strategy is determined by the conclusion, right? So strategy, conditional intro. Okay? Then our sub-strategy is determined by the disjunction. So sub-strategy is disjunction elim. And then our sub-strategy, right, in order to get the elimination of the conditional at line 3 is yeah, let's do it that way. So sub-strategy is negation intro. Right, so in each case, notice that what we're after is the conclusion of the strategic subproof, right? So the conclusion is C, so that we can generate the consequent of the conditional claim that is the conclusion. So assume the antecedent, derive the consequent. So we've got an assumptive move at line 4, an assumptive move at line 5, contradiction intro from 2 and 5, contradiction elimination from 6, assumptive step at 8, assumptive step at 9, an inference at 10, namely conditional elim from 3 and 9, a contradiction intro from 4 and 10, negation intro from 9 to 11, negation elim from 12, and then almost out, right, of the second disjunction elim subproof. Conditional, oops, I did the eraser. Conditional elim from 8 and 13. Then at line 15, disjunction elim from 1, 5 to 7, 8 to 14. And then our structuring subproof, the conditional intro, is 4 through 15. It's a long one, right? How are we doing? So far, so good? If you're up for it, let's try one more. We haven't worked a biconditional intro yet. And because I had I don't know what I was thinking with that one argument that suddenly just I don't know what I was doing, but that took up some time. So I want to make sure that we get what I hope is enough practice in. But I also wanted to mention that if you were comfortable with the way that we were working backward, but at times things went a little bit quickly, let me know, because we can always work that part of things more slowly. So let's try one more. So A, then B. A and B. Oh, I was about to mess up. If and only if S. And then the conclusion is A. Oh, I don't want to do that. Hold on just a sec. C, and then the conclusion is A if and only if C. I think I've got that right. Okay, so here the strategy is going to be biconditional introduction. So we're going to assume the left side of the biconditional, derive the right. Assume the right side of the biconditional, derive the left. So we can say, if I have A, then I have C, and if I have C, then I have A. In other words, I have A if and only if I have C. Okay, so we're setting ourselves up, telling ourselves what we're going to do so that by the time we get there, if we've forgotten what we were aiming for initially in terms of the structuring subproof, we've already written it down. Okay, now let's look at what we're given. We're given A conditional B. We're given A and B if and only if C. So we want to dismantle both. So how are we going to dismantle line 1? Well, take a look at line 3. So line 3 is an assumptive step. And we eliminate the conditional from line 1 by affirming the antecedent at line 3. Now we're in a great position. Take a look at line 2 to conjoin lines 3 and 4. So that we can eliminate the biconditional at line 2 by affirming the left side of it at line 5. Now we're going to begin the process again, only in a different order, right? So we start with C, assume C. From C, we can derive A conjunction B because we have eliminated the biconditional at line 2, right? By affirming the right side of it, namely line 7. Then notice, of course, now I have too much room, right? There are times when I don't kind of see the whole as I'm laying it out or as I'm, starting the structure. And so I don't make enough room or I make too much room. Anyway. So now at line 9, we can eliminate the conjunction at line 8. Right? And then that brings us to line 10, biconditional intro, 3 through 6, and 7 to 9. Okay. Thoughts?
This was probably the easiest one.
I wanted to end on an easy one, especially after, I don't know, I had my brain exploded for some reason. That happened.
Yeah, that last one was out of hand.
Well, now here's the thing though. The last one was actually really, really fun and easy and doable. The problem, as far as I'm concerned, is that I had like a meltdown before and was writing stuff that wasn't making any sense. And so I could see that would have thrown you off. But let's go back to this one though, Abdul, because I really do think that if we go back into it, so let's think about returning to this one, and after you've had a chance to do some more practice, and then when we return to it, asking, how we want to proceed. Well, let's say we're going to use the conditional intro strategy. So we assume the antecedent, draw a long line, assert the consequent, then get out of that subproof, right? And assert negation D then C, and then work backward from C. Where does C appear? Oh, it appears on the consequent side of the conditional in line 1, but the conditional in line 1 is part of a disjunction. So I'm going to have to dismantle the disjunction. In other words, the more we work backward, I think the easier it is to see the whole. Question for you though, since you were kind enough to say that you were a little bit overloaded by this one that we're looking at now, does the citation and justification for each make sense? Is there anything I've written that you can't make out or don't understand?
No, it makes sense. They all make sense.
Okay.
I think it was just what threw me off is getting to B. But I understand how you did it. It was just
yeah.
In the beginning, it was a little confusing.
Well, here's a question for you. So this happens to me. So I want to know if what I'm about to say works for you. If I looked at, so when I looked at the line 8, right, which says, let's assume B arrow C, because that's the right side of the disjunction, right? So I assume B arrow C, and I know that I want C, because as soon as I get C, I can get out of that subproof, right? And in getting out of that subproof, I also get out of the structuring subproof, namely the conditional intro subproof, right? But then I'm thinking, well, how the heck am I supposed to dismantle the conditional at line 8? How do I dismantle B arrow C when I don't have B? And if I assume I have B and I get C, how am I supposed to get out of that assumptives, right? So then I have to change the way I think. And I look at line 3 and I say, I haven't used line 3. And in fact, if I assume I have not B, I derive from that D, which contradicts line 4. And then I can eliminate the negation once I get out of the negation intro subproof. In other words, if I just sort of keep pulling things aside and talking my way through as I'm writing out how I can make something happen using the existing rules at hand, the whole starts to take better shape, right? But I'm with you on that.
On line 12, do we have to put double negation, or can we just skip to just saying B, or is this the structure? Do we have to follow that?
Great question. Answer is no. I go ahead and make that move just because that's technically what happens, right? If you start your negation intro proof with a negated sentence, when you exit the subproof, you introduce a negation, which now gives you 2, and then you eliminate them. But pretty much any system you go, any version of the system you go into, Abdul, you could just go straight to the affirmed sentence B.
Perfect.
Yeah. But I'm with you when you mention, gosh, how was I going to get there? How was I going to get the B so that I could get C? I do something similar where I'm like, oh, I'm not quite sure what to do. So then I try, just keep working backward. Okay.
Yeah, I can see myself working this problem in like an hour.
Yeah, and then it just gets, it goes faster and faster after a while. The other thing to not forget to do, folks, is this. If you get stuck somewhere, sometimes a brain reset is really helpful. And I do brain resets either by working something else or by literally getting up and walking away and coming back. Right? And you guys, we've been at this nonstop for almost 3 hours, for 2 hours and 45 minutes. It's a long time to just keep chugging away. So, give yourself, if, this was a really tough one to do toward the end of our session tonight, give yourself a break and just know, you might be shorting out. That's what and I think that's what happened to me. I've been in the classroom pretty much all day, or working pretty much all day. And, by the time I get to our session, I'm already a little bit fatigued. And then there are times when I just sort of short out and I have a little meltdown, and I'm okay, I'll fix it later, right? I'll walk away, I'll come back. So just know that that's normal. There's nothing wrong with you if that happens to you. Okay?
No worries.
All right, so questions, problems, confusions, let me know. Remember, let's play next week by ear in terms of what your desires are in terms of practicing and so forth. I want to make sure that everybody has the opportunity to vote if they haven't voted, and that's the priority, and that it's a really big election for us. Any election's a big election, but it's kind of a big deal, and I know we probably also want to watch the returns. So, if you, we can always make it a particularly short evening, okay, or late afternoon. All right, so thank you for being so patient and so dedicated, and I will plan to see you next week. But don't forget, I'm around office hours, also outside of office hours, okay? I'm here to help. I'll see you.
Thank you so much.
Thanks, everybody. Thanks, Abdul. Have a good one.
All right, see you next class.
All right, bye.